Alright, let's look at the product of series. This is called Cauchy product. Right? So if we multiply a series AN and series BN together, we can have a series of Cn where Cn is a summation from k equals 0 to n, ak times bn minus k. Right? So let's look at the motivation of this. Right? Let's think about the multiplying two power series. So say you have a summation, n goes from 0 to infinity. Then let's say you have an, x to the n. Then multiply by another power series. So summation, n goes from 0 to infinity, bn, x to the n. Right? So this is going to look like, I'm going to just kind of write it out. So it's going to be a0 plus a1x plus a2x squared, and so on. So I'll just so that's the first power series. And the second one is b0 plus b1x plus b2x squared plus, and so on. Alright? So collecting the like terms, if you multiply them out, you can see that let's say constant term would be a0 times b0, and that's it. So that would be the constant term. Alright, then a linear term would be a0 times b1 plus a1 times b0 x. Alright, and x squared term would be, we can get that by a0 times b2, right, or a1 times b1, right, or a2 times b0. And so on. Right? So you can see that this is going to be a0 b0 is really the same thing as c0, right? Because it's a0 and a b0. So this is going to be c0 plus, alright, this guy is c1, because if it's n is 1 and start from 0 and 1 minus 0, so it's a0 b0 b1. And then when k is 1, a1 and a b1 minus 1, so it's going to be b0. So this is c1x plus this is c2 x squared, and so on. Right? So you can see that this is going to be just a summation. N goes from 0 to infinity of Cn, x to the n. Alright, then we set x equals 1. Then you end up getting this Cauchy product. Alright, so that's the definition of Cauchy product. Alright, that's it. I hope that this was clear.